Hey everyone, Michael from ShadowTraffic here. Today we're going to look at generating relational data. If your application needs more than one data set, it's probably the chance that that data is actually related in some way. They probably need to share identifiers so your application can actually understand how to process it and maybe join that data. And so we're going to look at a really simple example today. I created a new configuration file, customers and orders. I'm running it again in sample mode to standard out and watching it to make development really easy. And we're gonna go ahead and get started. I have my configuration file filled out over here already. I've defined two connections, one for Postgres and one for Kafka. I'm just gonna stick with Postgres for the moment so that you can see sort of the basic example of how to share data across generators. But then later we're gonna show something more sophisticated where we actually show data being shared across different backends. And so I'm gonna go ahead and create just a really simple table for customers. And we're gonna write this out to Postgres. And what does a customer have? Customer has, well, just very simple for this demo, we'll say customer has a name because it's very readable. And a name is a string, just an expression, name of first name. We'll just kind of check that everything is in order. Looks good. And now I get an error here. It says a connection attribute must be supplied if you have more than one connection. Remember that if you have more than one connection, you kind of have to tell ShadowTraffic what the shape of the generator is. It doesn't really know, it can't really guess. And so we'll say that the connection for this one is for PG. That's my Postgres connection. I'll run it and I get a bunch of, looks like my generator didn't actually run. Why is that? Gen string, expra. It turns out that I'm missing a bracket here, so a little simple error. And now I have Cheryl, I have Helga, I have Clarice. And so that's probably enough just to demonstrate the point for customers. I'm gonna go ahead, I'm gonna make another generator here and I'll just copy this down. And so it's customers, now I have orders. And so what do orders have? Orders have probably two things. They have an order ID and then they have a customer that ordered them. So we'll do order ID. And this can be really simple. We could just say gen UUID. Great, so I got some order IDs. And now here's the critical part. Every order has a customer, but the customer has to already exist before the order comes through. Otherwise, it just doesn't make any sense. And so I'll say customer ID, and here we're gonna do the critical call. We'll say gen lookup. What am I gonna look up? I'm gonna look up, I have to sort of tell it where it is, what data collection to pull it out of. So it's in the customers table. And then what part of the customers table do I want? This is the last thing I need to give. I need to give it a path. And so I want the name, which is the column that I'm after. I'll run that. I'm gonna get, oh, here we go, actually, yep. If I run it, I see that I have a couple of different rows here. So customers is generated with a name of Casey, and then the next order that comes through is from Casey. And then I've got customer Marlene, and an order comes from Marlene. And it's not the case that like every previous customer that I generate is gonna create an order for the next person. They could be varied in some way. It's just randomly picking from the data set that's there. And so yeah, here you see I have generated customer Dale, and I have an order for Dale and customer Mickey, but the order is still for Dale. So it's just randomly choosing out of the collection of previously generated identifiers. So I want to push this a little bit further and do something more complex, because it's often the case that your backend, you have multiple different backends, and it's not just sort of like Postgres or Kafka. You're probably using Postgres and Kafka together. And so maybe more realistically, your customer data lives in Postgres, but your order data perhaps lives in Kafka. And so I'll go ahead and I'm going to change this over to be dev Kafka. I'll change table to topic, and instead of row, it's a value. And so I'll run that. I'll probably get an error here, right? And why will I get an error? It's because I've changed connections. It doesn't really, the lookup function just assumes that you're looking something up on the same kind of connections, looking up something in Kafka, and that's not the case actually. Now, what I'm looking up, I have to specify it and just sort of say, okay, it's in the Postgres connection in the customers table. I'll put that down here for neatness. And if I go ahead and run it, now what I'm doing is I'm generating customers to Postgres, I'm generating orders to Kafka, but I'm sharing those identifiers across these two things, which is really great because it makes it easy to model kind of your real data. The last thing that I want to show you in this tutorial is a little bit of a variation on the lookup. So as I said, when you perform a lookup, it looks at the previously generated identifiers and just grabs a random one. It's a uniform distribution, just equal probability, pick anything. But in the real world, it's probably not the case that that's what's happening. You probably have some population of that data is more likely to take action than another. And so one thing you can do on the lookup is you can stick in a histogram. And so this is a histogram, say gen histogram, and you give it some bins. You say across a population of 100%, with what frequency do I want to pull from it? And so this says the 20% of the population should take the action 80% of the time, and 80% of the population should take the action 20% of the time. And so what this has the effect of doing is saying, I'm making 80% of the orders from 20% of the users. Much more realistic than just picking random customers. And all I had to do was put in a little histogram. It's easier to see this if I turn up the sample size to say 20. We'll print out some data, and we'll see, if we sort of take a mental scan through here at Berto, we see this customer actually turn up a little bit more often than you would otherwise. It's no longer of equal probability. And as you get more and more customers, that 20% actually expands over the entire population, so it's fully dynamic. And so that's what I want to show in this video. Thanks for following along, and looking forward to the next one.